Why is correlation not causation in football data analytics? Imagine looking at a football data dashboard and seeing that teams with more completed passes tend to win more games. It might seem like passing more causes victories, but that's not always the case. Just because two things happen together does not mean one causes the other. This is the core idea behind why correlation does not equal causation in football analysis. Correlation simply shows that two variables tend to change in a similar way. For example, you might notice that teams with higher possession percentages often score more goals. But possession might be a result of a team's playing style, not the reason they score more. A team could have high possession because they are trying to protect a lead, not necessarily because they are better at scoring. This is called reverse causality, where the outcome influences the variable rather than the other way around. Another tricky part is spurious correlation. Sometimes two variables seem related, but it's just a coincidence or because of a hidden factor. For example, a player's number of completed passes might seem linked to wins, but it could be because the team is generally better overall. The real cause might be the team's overall skill level, not just passing accuracy. Without digging deeper, it's easy to jump to wrong conclusions. In football data dashboards, advanced metrics, and visualization tools, analysts can see these correlations clearly. But they must remember that these relationships are just patterns, not proof of cause and effect. For example, a dashboard might show that teams with more tackles tend to win more, but that doesn't mean making more tackles causes wins. It could be that teams behind in the game make more tackles to catch up, which is a different story. To really prove causation, analysts need controlled experiments or methods that isolate variables. But in football, that's hard because every game is different and many things happen at once. So, analysts should be careful when interpreting data. They should look at the context, like game situations, strategies, and external factors, before jumping to conclusions. Using data visualization tools helps spot these patterns, but understanding their limits is key. For example, a chart might show a strong link between a quarterback's completion percentage and team wins. Still, it's important to check if other factors like offensive line strength or the quality of opponents are influencing both. In the end, recognizing that correlation does not mean causation helps avoid false assumptions. It encourages analysts to dig deeper, ask questions, and consider the bigger picture. This way, they can make smarter, more accurate decisions based on football data rather than surface-level patterns.